Hi Lana, welcome to lesson 2 where we are going to look at CRO and TV tubes. We start with the CRO. CRO is cathode ray oscilloscope, and this one is an electrical instrument that is used to display and analyze waveforms. And as it displays them, then those waveforms, you can use them to measure the electrical potential, that is the voltages that vary with the time on the fluorescent screen. It has the following parts. We have electron gun, diffracting system, a fluorescent screen, and an evacuated strong glass envelope. We have this in the diagram. We have our electron gun that is coming up to that position. It has the cathode, it has the grid, it has the focusing anode and accelerating anode. Then we have the diffraction system that has Y plate and X plate. Then inside here is a vacuum. We are calling it evacuated glass envelope. And as we have seen earlier, we have seen that we evacuate to ensure that these electrons do not collide with any air particles. Then we have the screen where we have that when these cathode rays strike or fall on the screen, they are able to form a bright spot because this screen glows. From there, we move to electron gun. The work of electron gun is to supply electrons, to accelerate them towards the screen, and to focus them so that they form a point on the screen. It has the following components: 1 cathode, grid, and 2 anodes. In our diagram, this is what we call the electron gun. It has the filament. The work of the filament is to hit the cathode. This is the cathode. Then from the cathode we have the grid. It has a small opening here or a small hole. Then from the grid we have the anode. So those 3 parts, they form what we call the electron gun. So what are the functions of the cathode? The cathode, when it is heated by the filament, emits electron. So in other words, cathode supplies electron through the process of the muonic emission. Then from there, this cathode is coated with thorium and strontium, and these oxides, they have low work function. As we have seen earlier, this is because the work function is the smallest or the minimum amount of energy required for these electrons to be emitted. So if this energy is low, then it means that the electrons will be emitted easily. Then from there, we have the functions of the grid. We have that the cathode is surrounded with a hollow cylinder, and this cylinder has a small hole at the end. This cylinder is what we call the grid. The grid is at small negative potential relative to cathode. In other words, it is also negatively charged. It is connected to a negative terminal. So its purpose or its work is to control the rate of flow of electron. In other words, it's able to control the brightness of the spot or what we call the intensity of the beam. How does it function? The negative voltage on the grid can be varied. It can be changed by what we call the control knob. So if this grid is made more negative with respect to cathode, the number of electrons per second passing through the grid decreases. And this is because if it is more negative, it is going to repel many electrons away, and that will control them, or that will prevent them from passing through the grid. So if it is more negative, then small number of electrons are able to pass, and therefore our spot becomes darker. But if it is made less negative, we have that more electrons are able to cross over. And when they cross over to the screen, then the spot becomes brighter. From there we move to the anodes. We have 2 anodes. We have anode 1 and anode 2. Now anode 1 is at a higher potential than anode 2. The differences in this potential gives us what we call the electric field. And the direction of this electric field is in such a way that it converges this beam or these electrons. Now, the greater the potential difference between the anodes, the greater the electric field, and therefore the greater the degree of focusing. So as you are going to see in our diagram here, we are saying that the anode 1 is at a higher potential than anode 2. So the difference between the potential differences here creates what we call the electric field. And the direction of this electric field, as you are going to see, it is coming from the anode to, that is anode A1, to anode A2. That is the direction of electric field. It converges, it brings together the electrons, or what we are calling the cathode rays. So they are able to focus them. And we are saying that the greater the difference between the greater the potential difference, the greater the electric field intensity. And when the intensity of the electric field is high, then the focusing is also great, or the degree of focusing is greater. So again, we are saying that the potential difference of this can be varied to produce the desired degree of focusing. So that is the work of the anodes, to focus the beam. Then the functions we have: 1, the anode is positively charged and therefore it attracts the electron from the cathode. Then number 2, it accelerates the electrons by providing enough energy to cause the emission of light as they hit the screen, so they are able to accelerate them. Then number 3, they focus the electron so that now what reaches on the screen is just a point, or what we can observe from the screen is a bright spot, because they are able to, or the anodes are able to focus, they are able to converge and focus them to a point on a screen. Then from there we have the diffracting system. We have the functions of the diffracting system. 1 is to determine the position of electron beam on the screen. For example, if you want them to hit at the top, you use the diffracting system. So there are 2 of them. We have the vertical diffraction that we call the Y plate, and the horizontal diffraction that we call the X plate. We start with the vertical diffraction, what we call the Y plate. Now, as you can see here in this diagram, we have, they are made, or they make the beam to move either up and down. As you can see, we have the Y1 and we have the Y2. The Y1 is connected to the positive terminal and the Y2 is connected to the negative terminal. So the work of this one is to make the beam or the spot either move from B to C or to remain at A. So when the beam passes between the uncharged plate, when the switch is off or when the switch is open, as you can see, the beam is able to hit at point A. But when you connect the switch, or when the switch is closed, the Y1, this one, becomes positive because it is connected to the positive terminal. So the electron or the cathode rays are attracted towards the Y1, and therefore they are deflected, or they hit at the point B, because Y1 is positively charged, or it is the positive plate, and the cathodes are negative. But if we interchange the polarities, in other words, the Y2, if we connect Y2 to the positive plate and the Y1 to the negative plate, then you will find that this one, the deflection will change the direction, and our beam or our spot will move to point C. So that is when we interchange the terminals. The spot will shift to C through A. Then from there, if the DC is replaced by an AC current, remember DC is directional. It moves from the positive to the negative. But AC is alternating current. It reverses its direction within seconds. So if we replace this DC with an AC current, then the spot moves up and down. It oscillates up and down depending on the frequency on the AC. Now, if the frequency is high, then we see a vertical line. Because now, if it is high, then it means that the spot will be moving at a higher rate. And because in our eye, we have what we call the persistence of the vision, then we observe a straight line. Then from there, the plate causes the deflection in the vertical direction. That is up and down. And that is why we call them the Y plates, because they cause the deflection in the vertical direction. Then from there we have the assignment. So the assignment are just testing what we have just learned. So attempt the assignment with positive attitude and you are going to get everything. So thank you, and let us meet in our next lesson.